Okay, good morning or good afternoon, whatever time of the day it is. I want you to go ahead and either in your notes or your homework, here's our warm-up problem. Okay, I'm going to make you think outside of the box a little bit. I know that's scary, but I have a limit here. And notice how there is a K. All right. I want to know what would K need to be in order for this limit to exist. So in your notes or your homework somewhere, go ahead and try to figure this out. Okay, so let's think about this. In order for this limit to exist, that means, okay, right now we're plugging in 2, and you can see that our denominator would be 0. That's not okay, but we need something algebraically to happen to where that x minus 2 is going to cancel out. So when we talk about the limit as x approaches 2 of this rational expression, we need x minus 2 to be canceled out from numerator to denominator. Okay? Now, if we have x minus 2 in our numerator, we need k to be something to where when we multiply these two binomials together, we get x squared plus x plus a number. So when I think about us foiling, our inside and outside need to add to be x, while our inside is going to be negative 2x. If I want the outside to add with negative 2x to be that x, it's going to need to be 3x. Okay, now we can cancel out those x minus 2's and actually evaluate the limit. So if I FOIL that out, what is k going to be? K needs to be negative 6. Okay. All right, so just a little thinking outside the box there. What I want to do now is talk about one of your homework problems. 86 is even, and I was concerned about us maybe having some trouble with the algebra, so I thought I'd go over it. So number 86 was one of our difference quotient problems. So we need to take the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, which means we have the limit as h approaches 0 of the square root of x plus h, minus the square root of x all over h. Okay, so some of you might have gotten here and said, what do I do next? Remember, when we have, well, first of all, let me back up. trying to plug in 0 for direct substitution would give us 0 over 0, and that's not okay. So algebraically, we need to do something. So I'll remind you that if we have the sum or difference of at least one radical, we can use our strategy from the other day of multiplying by the conjugate. So here I have a minus b. Let's multiply by a plus b. And remember, whatever we do to the numerator, we have to do to the denominator also. Okay, so now when we multiply a plus b and a minus b, we always get a squared minus b squared. Okay, so now our x's cancel, and we're left with h over h times this conjugate. Those h's cancel, and we can now use our direct substitution. So 1 is left in our numerator because the h is canceled. We have the square root of x plus 0 plus the square root of x. So we end up with 1 over 2 square root of x as our answer. Okay, things I want you to notice. I wrote the limit as h approaches 0 every time until I actually plugged 0 in for h. That is an expectation I will have for you. Okay. All right, whoever is in charge of playing this video for class, I want you to go ahead and after I give my instructions, pause it. What's going to happen is we're going to take a homework quiz. So on your desk, you can have your homework out and a pencil. No calculator is needed. But with your homework, the sub is going to hand you a homework quiz. There's only a few questions. They should all be very, very similar to problems that you've had in your homework. So I want you to use your homework to help you complete your homework quiz. The sub will give you about 10 to 12 minutes, and then you can continue with the rest of this video for our notes. Okay, so person in charge of the video, go ahead and press pause, and let's take a few minutes to do our homework quiz. Okay, so today we're going to talk about one-sided limits. What we're going to do is we're going to talk about just the introduction to what a one-sided limit is today. And then we're going to take a time out and review what we've learned tomorrow and take a quiz on Monday, like an official quiz. So that homework quiz that you took today, I'll get those graded and back to you somehow, more than likely digitally. So look for those in your email inbox. But I'd like to give you some feedback on your homework quiz to help you with your actual quiz. So we're going to talk about today what a one-sided limit is, and then next week we can continue with what we can do with one-sided limits to kind of help us with one of the definitions we get to learn. But today we're just going to focus on the notation and how we find them graphically and a little bit analytically. So one-sided limits, we're basically talking about separating approaching from the left from approaching from the right. Okay, so first we have the limit as x approaches 2 from the left. In this, notice how 2 has a little superscript of a negative. That means we are approaching our limit from the left side. When we talk about the notation as x approaches a value from the right side, here's how we notate that. We have a superscript of a plus. This means we are approaching the limit from the right side and the right side only. Okay, so to determine these one-sided limits, we're basically going to drive our car on the curve, but only from one side. So we're thinking about what y value our car is approaching as we're driving along our curve from either the left or the right. Okay. So let's think about this. 4x squared minus 5. We know that that is a parabola shifted down 5 and is stretched pretty significantly. Okay. Here at x equals 1, what's happening is I'm asking you for the left-handed limit. So I care about what's happening only from the left side. So as we drive our car only from the left side, okay, only from the left side here, it looks like we are approaching a -1, okay? Now, in this instance, it is no different than if I asked you just for the limit as x approaches 1, but we're just kind of trying to get an idea of wrapping our head around this, okay? Let's look at this one. This is a graph that I want you to recall and be familiar with, okay? The equation of a circle is x squared plus y squared equals r squared. Okay, if we solve for y, we would subtract over our x squared, and then we would square root both sides. And remember, when we square root both sides, we would have that plus or minus. Okay, so notice how this looks similar. Okay, this right here is a semicircle. And since it's the positive semicircle, it's the one that is above the x-axis. So what we have going on here, let me get this out of the way for us. We have the semicircle with a radius 2 that sits above the x-axis. Okay, so notice how our limit is as x approaches -2 from the right. Well, here's -2 right here. We can't approach it from anywhere but the right side. So as we approach it from the right side, okay, we see that we're approaching this coordinate right here. So we know that this is 0. Okay. The biggest thing that I'm worried about, well, there's two things that I'm most concerned about. Number one, if I give you a graph and I ask you for right-hand limits, left-hand limits, normal limits, can you pick those out? Okay, so let's go through this graph and look at a couple things. So first, I want to ask you for the limit as x approaches -1 from the right. Okay. If we are coming from the right, here's -1. If we are coming from the right side of -1 and we drive our car, see if I can actually fit, there's my car. Okay, so as we come from the right side of -1, it looks like we're approaching that coordinate right there, which has a y value of 1. There we go. Okay, now what if I ask you for the limit as x approaches 1 from the right? The left. From the left, if we drive our car from the left side of 1, okay, it looks like we're approaching that coordinate right there, which has a y value of 2. Remember, we don't actually have to have a coordinate. We're getting super duper close to where we're almost touching it, but we're just approaching, right? Okay, so you can see how the right-hand limit and the right-hand limit and the left-hand limit are different. Okay, so what does that mean? Well, when I ask you, that's probably not a great color, for the limit as x approaches 1 of g of x, notice how it's not from the right, it's not from the left, it's 1, so it's from both sides. Well, since the right and the left-hand limit don't match up, our limit does not exist. So we can say that it exists from the right, and that is 1. It exists from the left, and it's 2, but when we smush them together, the limit as x approaches 1 doesn't exist since the left and the right are approaching different values. Okay, so I'm going to give you a couple to think about. The limit as x approaches 1 from the left of g of x. The limit as x approaches 3 from the left of g of x. And the limit as x approaches -3 from the right of g of x. Turn and talk to a neighbor about these 3 limits and what you think they should be. Okay, so from the left side of 1, it looks like we would be approaching 3. From the left side of 3, it looks like we would be approaching a y value of 0. And from the right side of -3, it looks like we would be approaching a y value of 1. Okay. All right, so let's get a little bit more practice with this. See if I can get it. There you go. So I have 8 problems. Some of them are limits, some of them are one-sided limits, and some of them are function values. So here's your graph right here. I want to see if you can complete these 8 problems. We'll go over them, okay, but I'm going to give you a couple minutes to see if you can get some answers here. Feel free to turn to your neighbor and talk about them if you need to. My suggestion would be once you get your answers to compare them with somebody next to you anyway, and then we'll talk about them as a class. So I'll give you a couple minutes. If you haven't done so already, go ahead and turn and talk to your neighbor about your answers or the answers you have so far. Okay, if you need more time, press pause, but we're going to go ahead and go through these, okay? So decide as a class if we need a pause. Here we go. The limit as x approaches 0. Here's x is 0. From both sides, it looks like we are approaching that y value of 2. Number 2, the limit as x approaches -3 from the left. Here's -3 from the left. It looks like we're approaching that open coordinate, which has a y value of 0. Then we have approaching -3 from the right side. So here's -3. So from the right side, we're approaching this coordinate, which has a y value of 2. And since those two are not the same, then the limit as x approaches -3, we would say does not exist. Okay. The limit as x approaches 2, the limit as x approaches 2, here's 2. From both sides, it needs to match. It looks like we're approaching that hole, which has a y coordinate of 2. But then our function value is our closed circle, which is at 1. Now, something I want to talk about very quickly. The first homework assignment that you had, there was a question. I don't know if it was like 72 or 60, 66, one of those problems, okay? It asked you, if you have it was number 60. If you have the limit, what do you know about the function value? And then it asks you backwards, if you have the function value, what do you know about the limit? The two have nothing to do with each other, and here's the perfect case. We might have a limit that is different from our function value, and we won't really know if they're the same. Sometimes they are, sometimes they're not, okay? In a polynomial function, they'll always be the same. But here in this piecewise function, they're not the same. So we cannot assume ever that since we know the limit, then that directly correlates to our function value. Sometimes they're the same and sometimes they're different. So just because we know one doesn't mean we know the other. When they do match up, that is going to be something special we talk about next week. But just because we know one doesn't mean we know the other, and here's the example of why. Okay, next we have the limit as x approaches -1. Here's -1. So as we approach from both sides, it looks like we're at the y value of 2. And then the function value at -3. Okay, we're looking for our closed circle. Here's -3. Our closed circle is here at 2. Okay, we'll do a little bit more practice with that tomorrow. Okay, here's the next important thing I want you to be able to do. So we've done a lot of work graphically, and as you've noticed, the piecewise functions are what makes the graphical limits so important. Okay, in terms of looking at the right side and the left side. Okay, if I come back up here, right, we have a break here and we have a break here. Place number 1, the limit did not exist, but place number 2, the limit did exist. So with our piecewise functions, we need to be careful. Do they match up like they did here, or do they create a jump like they do here? That's what we're going to need to be able to do analytically. So go ahead and write down this function, h of x. And notice how I'm asking you for the limit as x approaches 0. And that is exactly where we have the break in the domain. Okay? So since this is a piecewise function, and I'm asking you for the limit at this break in the domain, we are going to need to use a right hand and left hand limit to determine what this is. Okay, so first let's talk about the limit as x approaches 0 from the left side of h of x. Well, x is less than or equal to 0, that would be the left-hand side of 0. Okay, that would be to the left. So we can plug 0 in to this x plus 1 piece. Okay. Then we need to look at the limit as x approaches 0 from the right side of h of x. Okay, x is greater than 0 would be describing the right side of 0. So we can plug in using direct substitution to this piece right here. Okay, because these two are the same, our left hand and right hand limit, then we can conclude that the limit as x approaches 0 of h of x equals 1. Okay, so let's review what we just did there, okay? We had a piecewise function where I was asking you for the limit at the break in the domain. Since the limit is at the break in the domain, then I ask you to look at the left-hand limit and the right-hand limit. Decide which piece to use. This piece we used for left, this piece we used for right, and since they matched, we could say that that was our limit. When you have a quiz here in a couple days, I will expect all of this work for a full credit answer. Okay. Now let's look at the graph here. This is the graph. So we have the piece of x squared plus 1, and we have the piece of x plus 1. And notice how, as we approach from the right and the left, we're approaching that coordinate with a y-coordinate of 1. Okay. Okay. Hopefully you remembered this graph a few moments earlier. Remember our graph, absolute value of x over x looks like this. So when I have the absolute value of x minus 5 over x minus 5, then we're just going to shift that 1, 2, 3, 4, 5 to the right 5. Okay, so if I ask you for the limit as x approaches 5 from the left, then you would tell me -1. If I ask you for the limit as x approaches 5 from the right of f of x, you would tell me +1. And if I were to ask you from the limit as x approaches 5, you would have to tell me it does not exist because the right and the left hand limits are different. Okay. All right. We're going to skip that one. Last example for us here. So hang with me. Last example. Go ahead and write it down. And we're going to look at the limit as x approaches -1. That's what we need to determine. So since I'm asking you for the limit as x approaches -1 of a piecewise function where that is a break in the domain, we are going to have to look at one-sided limits. Okay? So let's first look at the limit as x approaches -1 from the left. All right, the left side of -1, which piece would that be? X is less than or equal to -1 is this piece. So we're going to use direct substitution for that piece. Okay. Then we're going to look at the limit as x approaches -1 from the right side. Okay, well here x is greater than -1, so we're looking at this piece right here. So I'm going to use direct substitution with that piece in order to figure out the right-hand limit. Okay, what does this mean? Since these two do not match, then the limit as x approaches -1 does not exist. Okay, so now it's time to look at your homework. Just like yesterday, I will be available on Zoom tonight for your class from 7:30 to 8.